Hey everyone, welcome to day 2 for April, and today's question is isomorphic strings. Now, what exactly are isomorphic strings? For example, EGG and ADD, right? So, we should be able to replace alphabets in the same pattern as the first string and the new string. For example, S and T would be isomorphic if, uh, you know, let's say the pattern is XYY, then the pattern here should be XYY as well. For example, EGG, ADD. Similarly, PAP, TIT. And these two are not isomorphic because foo bar. So it's like XYY, and we have ZMN. Like we literally have no relation here. So these two are not isomorphic. So how do we solve this? Now it's quite easy. Basically, we first need to understand how we can map every alphabet to the other alphabet. So let's quickly go to the whiteboard actually. Okay. So for example, E, G, G and A, D, D. Okay. So we have to just map them E to A, G to D and G to D, and we'll create a set of these mappings. So if we create a set, this last G D mapping would not exist in that set because sets have unique values. So we'll have E to A and G to D. Now if you observe, the length of this set is exactly equal to the length of the string set. So if I take EGG, the number of unique characters here will always be equal to the number of unique pairings if those two strings are isomorphic. ADD. So unique characters are A and D, E and G, and we have two pairings. Similarly, let me get a different color. PAPER, and then we have TITLE. So this mapping basically is more like a pattern. So don't worry about the values here. So P to T, then A to I, P to T again, E to L, and V to E. As you can see, PAPTITLEEV. So this is isomorphic. And if I get the unique pairings, it will be this P to T will be removed. So P to T, A to I, E to L, and V to E. And what are the unique alphabets in each strings? P, A, is not unique. Let me get this in green. So P, A, E, R, and for this one we have T, I, L, E. So the length is 4, right? And the mappings that I have is also 4. So what I basically need to do is I need to create a set of this mapping, check that set's length with the set of this, the length of this set and the length of this set. If all three are equal, then yes, they're isomorphic. And this is fairly easy in Python. Let's go code it directly now. Let's start the timer. Now what we have to do is first let's fail faster. So if length of s is not equal to length of t, then just return false because they have to be the same length for this to work. Now just return uh, how you create a mapping in Python is by using zip. So length of set of zip of s and t. So this basically gets you the length of the mappings. Then that should be equal to the length of the set created with the alphabets in S, which should be equal to the length of the set created with the alphabets in T. And if I run this, there you go, accepted. And if I submit, accepted, nice, 88%, which is good, and 64% because I'm not really using a new data structure, sorry, not data structure, memory here. So this looks good. Okay then, I'll see you in the next one.